Hello everyone. In this video, we will learn about aldehydes and ketones. Aldehydes, as you know, has a functional group C double bond OH, whereas ketones have the functional group C double bond O. Let us begin with the nomenclature. Aldehydes are generally named as alkanal. So an aldehyde with one carbon atom would be methanal. One carbon atom, double bond OH. This is the aldehyde functional group. So one carbon atom is already used up in the functional group. So then we just have a hydrogen. We can also write methanal as HCHO. The next member in this homologous series would be ethanal. Eth means two carbon atoms. The end carbon you put it as CHO. So CH3CHO would be ethanal. Propanal is the next member. Three carbon atoms. The end carbon is CHO. This would be propanal. What if there is a double bond? So let us do an example. CH3, CH, double bond CH, CH2, CHO. How will we name this compound? There are 5 carbon atoms and you start numbering them by giving priority to the aldehyde functional group. So this would be your carbon number 1, 2, 3, 4 and 5. So here the root word is pent because there are 5 carbon atoms. There is a double bond at the third carbon. So we call it pent 3-ene and al. So this would be pent 3-enal. Let us do a few examples. Here, the number of carbon atoms is 1, 2, 3, 4, 5, 6 and 7. So the root word would be hept. There is no double bond, so AN and the aldehyde group AL. We have a methyl group at position 3 and a bromine at position 4. We consider the bromine first because alphabetically bromine comes first. So we say 4-bromo. Bromine is in the 4th position. So we say 4-bromo. And in the 3rd position, we have the methyl. So 4-bromo, 3-methyl heptanal. So here again, we have a double bond. We start counting from the aldehyde carbon. So there are 5 carbons. We put a pent. There is a double bond in the 2nd position. The double bond is coming between carbon numbers 2 and 3. So we say the position of the double bond is carbon number 2. So this is pent 2-ene. Al. That's it. There are no substituents. So this compound is called as pent 2-enal. This is a different kind of naming. You can see that there is a cyclohexane ring and a CHO. We cannot call it as a cyclohexanal because there are not 6 carbon atoms but 7 carbon atoms including the CHO carbon. So here we adopt a different style of naming. We call this as cyclohexane carbaldehyde. Cyclohexane carbaldehyde. So cyclohexane ring and the CHO is called as carbaldehyde. Here again, we go for a different style of naming because there are 3 CHO groups. So we consider the straight chain. There are 3 carbon atoms in the straight chain. So we call it as propane. And there is a CHO on each of the carbon atoms of propane. So we call it as propane 1, 2, 3 tricarbaaldehyde. Propane 1, 2, 3 tricarbaaldehyde. This is benzaldehyde. It is also called as benzene carbaldehyde, but more commonly known as benzaldehyde. This is a substituted benzaldehyde. So we start numbering from the CHO carbon. So 4th position, we have a nitro group. So we call this as 4-nitro benzaldehyde. 4-nitro benzaldehyde. Next, we come to the nomenclature of ketones. Ketones are called as alkanones. The first member of the ketone series requires 3 carbon atoms, right? Because there has to be a C double bond O, and it has to be compulsorily attached to 2 different carbon atoms, 2 other carbon atoms. So there should be a minimum of 3 carbon atoms for a ketone. So the first member of the ketone series, which contains 3 carbon atoms, is called as propanone. The next member would be butanone. This would be butanone. The next member, pentanone, we can have 2 isomers. Here, the double bond O, the functional group, is present on the second carbon atom. So we call this as pentan 2-O. Whereas if the functional group is present on the third carbon atom, we call it as pentan 3-O. This is how you mention the position of the functional group in ketones. So let us do a few examples. So here the longest chain contains 5 carbon atoms. So you have a pent. There are no double bonds. So you put in the AN, pentan. Then the position of the keto group is the third carbon. So pentan 3-O. We also have substituents, methyl substituents on second and fourth carbon atoms. There are 2 methyl substituents, so you call it as dimethyl, and the position 2 and 4. So the name of this compound would be 2,4-dimethyl pentan-3-O. This is cyclopentanone with a methyl substituent. So 1, 2, and 3. The third position we have a methyl group. Otherwise, this is a cyclopentane ring. So we call it as cyclopentanone with a methyl group substituent in the third position. So we call this as 3-methyl cyclopentanone. Here, we look at the carbon chain. So 1, 2, 3. So this is propanone, and the double bond O is present on the first carbon. We also have a benzene ring on the first carbon. So this would be propan 1-O with A phenyl substituent, benzene ring, when it comes as a substituent, is called as phenyl. So we say 1 phenyl propan 1 O is the name of this compound. Now here we have two functional groups. We have the aldehydic functional group and we have the keto functional group. The priority is to the aldehyde. We number it in such a way that the aldehydic carbon gets a lower number and we also name it as an aldehyde. We put in the suffix al. The double bond O is considered as a substituent called as oxo. So this compound would be named as, there are 5 carbon atoms. So we have a pent, no double bonds or triple bonds, so AN, pentanal. And third position, we have an oxo substituent. So this is called as 3-oxo-pentanal. Let us do a few more examples. Now look at this compound, CH3 twice CH-CHO. Now here we have CH3 twice CH. So when we draw the structural formula, you have this carbon atom on which you have 2 CH3 groups. So that would be CH3 twice CH and CHO. So now the longest chain would be 1, 2, 3. It is a propane. So this is propanal with a methyl group in the second position. So this is propanal with a methyl group in the second position. So this is 2-methyl propanal. 2-methyl propanal. Here again, let us draw the structural formula CH3, CH, and they put it in brackets. That means it is a branch. OCH3, CHO. So here again we have 1, 2, 3 carbon atoms. Second carbon, there is a methoxy group. So this would be called as 2-methoxy-propanal. 2-methoxy-propanal. So here this is 3 carbon atoms. So prop, aldehydic carbon is numbered as 1. Between second and third, there is a double bond. That means position of the double bond is 2. So prop 2 enal. The compound is called prop 2 enal. Here we have CH3 twice CH again. So CH, CH3 twice. CH3 twice CH. CO means C double bond O. CH, CH3 twice. So we've already done this compound. We've already named this. This is called as 2,4 dimethyl pentan 3-O. 2,4 dimethyl pentan 3-O. Now here again we have CH3 twice C, CH3 twice C, double bond CH, C double bond O, CH3. So here we have a double bond and the keto group. Keto group will get the priority. So we will number it 1, 2, 3, 4, 5. So we have pent. Between 3 and 4, there is a double bond. So position of the double bond is 3. So pent 3-ene. And on the second position, we have the keto group. So pent 3-ene 2-one. And this is 4-methyl. So 4-methyl pent 3-ene 2-one. This is the name of the compound. Before we conclude, let us have a look at the structure of the carbonyl group. The carbonyl carbon, the C double bond O carbon is sp2 hybrid, which means it has a trigonal planar structure, right? It has a trigonal planar structure. There is an unhybridized p orbital on carbon which overlaps with the orbital of oxygen to give the pi bond between carbon and oxygen. So carbonyl carbon is sp2 hybridized and it forms 3 sigma bonds, and there is 1 pi bond between carbon and oxygen. Now the carbonyl bond, the C double bond O bond is polar. So this is the C double bond O bond. We know that oxygen is more electronegative than carbon. So the pi electrons from the carbon-oxygen double bond will shift towards oxygen, giving it another possible structure with carbon positive and oxygen negative. So there is a resonance between these two structures. Now, as you can see, the carbonyl carbon has a positive charge, right? In the second resonance structure, we saw that the carbonyl carbon has a positive charge and therefore it is an electrophile. It attracts electron-rich reagents. And the carbonyl oxygen is electron-rich. So it is a nucleophile and it will attract electron-deficient reagents. And all carbonyl compounds have very significant dipole moments because of this polarity, and they are usually more polar than ethers. With that, we come to the end of this video. Thank you for watching. Hope you have understood.